Hello there, Nara is here. Today I'm going to solve the second exercise from 2017 session, no, the second session of chemistry. So let's start NiAg electrochemical cell. In order to construct a functioning NiAg electrochemical cell, a grade 9 student proposed two labeled schemas represented in document 1. So in document 1, the schema 1, we have silver strip in Ag+, and nickel strip in Ni2+. As for schema number 2, silver strip in Ni2+ and nickel strip in Ag+. Choose which of the schemas correspond to the NiAg electrochemical cell and justify. We have to choose the first one because you have to immerse a silver strip in Ag+, its corresponding ion. A nickel strip, it has to be immersed in Ni2+ solution. So that's why you need to choose schema number 1. As for schema number 2, you cannot choose to immerse the silver strip in Ni2+. That's the main reason. Among these two metals, nickel is more active than silver. So what does it mean nickel is more active than silver? It means that the nickel will lose electrons more easily, though, so the nickel will be the anode. Identify the anode of this cell, so it's nickel because it has a higher tendency to lose electrons than silver. Indicate the direction of the flow of electrons, so the electrons will flow from the nickel, which is the negative pole of this electrochemical cell, towards the Ag strip. All right. Recopy and represent on the axis given below the placement of the nickel metal. So the nickel metal, since it has a higher tendency to lose electrons, it will be on the right side. So this is where you should place the nickel. So let's write it here. This is where you should place nickel, it on the right side because it has a higher tendency to lose electrons. During the functioning of this electrochemical cell, half reactions take place at the level of the electrodes. Write the half reactions that take place at these electrodes. So we have at the anode, which is of course an oxidation, half oxidation, we will have Ni losing 2 electrons and being transformed to Ni2+ ion. As for the cathode, at the cathode we will have half reduction. It will be silver, it's Ag+, plus 1 electron gives you Ag. Now, deduce the overall redox reaction. In order to deduce this reaction, the overall reaction, we need to multiply this reaction by 2. So we will have 2 Ag, 2 electrons, 2 Ag. So 2 Ag plus 2 electrons and 2 Ag. You need to have 2 electrons on the left and right side of your equation. The overall reaction will be Ni plus 2 Ag plus. It gives you Ni2 plus 2 Ag. All right. Deduce the overall. Okay. Specify the reductant reducing agent in the overall redox reaction. So the reductant actually is the one which is going through an oxidation. So it's the Ni strip, which is the reductant, and it's going through an oxidation. One of the students suggests the following incorrect representation of this cell Ag+, Ag, salt bridge, Ni, Ni2+, as the symbolic representation of the NiAg electrochemical cell. Give the correct symbolic representation of this cell. In order to make the symbolic representation, you need to put the anode on the left side. You start by the anode and then you reach the cathode. So you need to start by Ni, Ni2+, Ni2+, salt bridge, and finally see you. Today I'm concentrating on Cu. All right, so Ag plus and Ag. That's the symbolic representation of this electrochemical cell. So yeah, that's second exercise from session 2017, the second session, chemistry. I'm gonna ask you to subscribe to my channel. You'll be notified whenever I upload new material, new videos. I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. That's all for this time, and see you.